Hello and welcome to the next laboratory work called Pick and Place Boxes, where we are going to solve this task by using industrial robot from ABB sample. In this task, we are showing how to download the solution, or ready-made solution for ABB Robot Studio, which we are using for our task. Then we cover a theoretical part about the pick and place task in general. Then we show you how to unpack ready-made solutions in ABB Robot Studio. Then we show you how to teach positions with different options. And then we write the code to pick and place the task by using different function additionally. And in the end, we show you a ready-made working solution in Robot Studio. In this part of the video, we are going to show you how to download the ready-made solution for the pick and place task from the Teams application. So the solution can be found in the Teams window where we have opened now the course main page. So you go down, you can see here, and then we have this course materials. Under this course materials, we will now open the folder system, and here we have practice and lab work 2. And under model, you are able to now have this file and we download it. So you click here, download, it's in Estonian laadi alla, and it will download it directly to the download folder on your computer. So there it's located there. Now we are going to cover the theoretical part about the pick and place task on industrial robots. So first we need to determine how many positions do we need for executing the pick and place task with a robot. So first I would always start with the positions to teach which we can exactly position. In our case we have this pickup position here, and the other one is place position. Why they are exactly? Because we know where the objects are located or where the placeholders are, and we can very easily teach them correctly. However, we are not able to go directly by the gripper to the box itself to pick it up. So we need an upper position here, which allows us to move safely to the box itself and grip it. And this position I will teach after I have taught the pickup position here. So I only would, let's say, move it up some certain distance and then teach this upper place for the robot program. Same goes with placing position. So first I would teach the place here where I have the box in here, and then I go to the upper part directly up and teach that one. So here you can see that in general we would need 4 or in some cases even 6 positions to execute the one box pick and place task. However, we are able actually to use some calculations inside the program or even some functions which allows us to calculate some positions. And for these purposes I would choose, let's say, upper parts. Why them? Because they are easily changeable. The exact positions like pickup position and placing position I would teach, but all the upper positions I would calculate in the program or use the functions to do that for me. Now we need to decide to which motions we should use to move between taught and calculated positions. In this case we have 2 options. One is linear motion and the other one is joint interpolation motion to execute the program. Move linear is where the robot moves the TCP in the robot system straight. Move J is a little bit different because it's executed randomly and we don't know exactly how it moves before we have not seen it in real life. So these 2 options we have. I would say that from the unknown position, let's say where the robot is located, we can use move J to go to the upper position of the pickup place. When we have it, then we need to move straight down and grip it, and then move straight up so that we can move without collision other objects or colliding with other objects. Then we should use, if possible, straight motion to upper position of the placing part. When we have it, then we should move down to the placing part here, release the gripper, and then move up to the upper position. Why up? So that we can actually access the box after the robot has stopped the work of itself. In some cases, we may need to use move J to move from upper position of pickup place to the upper position of placing position. But we have to see if it's necessary or not. So if the robot is not able to execute move L command, then we go with move J command. But all the other motions should be used as move L commands. So here you can see the full diagram for the pick and place task, which consists of the positions and necessary motions. In upper part, we have this move joint options, which allows us to move the robot best between different positions. And then up and down motion, we should use only linear motion because we want to avoid collisions between the box and the table, which will harm, let's say, the box. And as you can see, sometimes it's possible to also have a linear motion between upper positions. So if possible, you should use always linear motion, and when not possible anymore, go with move J command itself. So next we are going to show you how to unpack a ready-made solution which we have already downloaded onto our computer in ABB Robot Studio. To open the downloaded solution, we go to Files. Here we have then the Share option and Unpack and Work function. Now it opens a new widget where we have to carry out with the next, and now we have to check for the location of the file. It's normally under this PC, and then you go to the downloads, and on downloads we have this file. So you click on Open, and now I have this warning here, which means that it doesn't like the length of my folder, so I have to change it. Maybe you don't have this problem, so don't do it. If you don't have, I go this way because I need to do it, and I have to specify additional file folder name, say one, and I go now next. Now it asks me about the library files. I say that it's good to be from the PC, and on this application it also doesn't matter. Then I have to select robot where. In our case, I have only these two. 7 I cannot use because it's not supported by this robot which we have in the application. You see this warning, let's say. And when I take this one, then this is actually fine for me. So 6.3, 13 is good for me. Next is the final summary of the unpack function, and now I click on finish. It takes a little bit time to unpack all the necessary files, to open it, to download, and to run all the other applications. And now we have to just be patient a little bit and wait for it to finish it. So now we have managed to almost unpack everything. So it warns me that I'm opening this application on the older Robot Studio, but it doesn't matter. It's fine for me. I click on OK. And now I can see if it's going to run the future control or not. Yeah, you can see this is red at the moment, but it goes to green, which means that it managed to open and unpack everything successfully. So I click on close, and this is the end result out. It should be shown when you manage to download it and open it successfully. If you have problems with it, let's say you don't manage to see it, then try to another computer. Maybe your graphical doesn't support a 3D environment, or if you have no virtual controller like this one here, then I do recommend to try to unpack and work again function. And if it's not working, then please contact me and I will try to help you over Teams or other applications for your help. Now we start with the position teaching in ABB Robot Studio.
First, we start with the home neutral position on the robot part. At the moment, you can see that this is the initial state of the robot, and we don't like it because the grip, or let's say the vacuum gripper, is not oriented as we need. We need to point down, and for this, let's make right click on the robot itself, then choose mechanism joint choke, and in here we can select, let's say, the fifth axis, and we can write 90 and enter. And with this, we have now the gripper pointed directly down. For our case, it's very good. So we will teach this position by using teach target. Yeah, it asks if we want to teach because it's saving under work object 0. It's fine for us. We can say yes. And you see here that the position has been successfully talked as, and the name is target 10 for our solution. Now we need to move the robot, the gripper, let's say, to the blue box. And for this, I would activate first the snap center. And then I go here and select this move command from freehand. As you can see, there are some axes which I can select and move it. But I need to click on the vacuum gripper itself, and then I can, let's say, select the green arrow and move it to the correct place now. Here you can see I have collision, so this means that I need to move it up a little bit because otherwise I'm not able to grip it. Here you also can see the collision warning and also text here. I deactivate the center because I want to move it up a little bit. Okay, maybe a little bit more. You can see that there is some space between the gripper and the box. And now I can test if this is fine for me or not. I go to simulation, I select IO simulator. In here I go to SC vacuum gripper and I click on DE grip. As you can see, this went now 1 and also the output went 1, which shows that I successfully gripped the object. Now I teach this position, I go home tab and then teach target. Yes. Now I have the second position, then I go to the place where I want to move it. So in our case, we have to put the blue box here. I grab it like this, I move it this side, I move it in here, okay, a little bit back, a little bit this way, and now I can move it up more and more. Still collision, so I will move it up more, and now no collision anymore. But the box itself, as you can see, is inside the placeholder in the palette, and I will teach this position by teach target. Yes. Now I have two positions for the blue box. One name is target 30 and the other one is target 20. So this way we should teach all the other boxes too, like the red and the green one. In the end, we should have the boxes placed like you can see here in this window. That the blue box is here, then we have the red box, and then we have the green box located here. I do recommend to switch off the gripper if you have taught all the positions. Then the other part, be careful with this move function here or rotation function, because it can not only move the, let's say, the robot tool itself, but it can change the location of the components. So if you don't need to use it anymore, then deactivate it. So how many positions we have? If we go to paths and targets, then we open this robot folder, like you can see here, this way. Then we have in total 7 positions. So 2 positions for each box. If you want, you can rename it. So select the box position which you want to rename, right click and select rename, which is under here. Okay, not visible, so good. But in general, all the positions are here, what we need for our program creation. With this, we are ending this video here, and we are continuing in second video part with the pick and place laboratory work.
by programming the robot and later on testing the simulation in ABB Robot Studio.